Hi, my name is ManikaRaja and I'll be presenting part 2 of my final project presentation for harvesting, storing and retrieving data. Part 2 of our presentation, we were provided with a data file, a CSV format file, which was supposed to be pre-processed. Analyzing this data set file, we do see that the columns are not missing any values and it includes the provided information. The data file is a CSV file in which each field is a record is separated with the next one by commas. To analyze this data, I decided to use OpenRefine. OpenRefine is an open source data cleaning and transformation application used for data wrangling. So we uploaded the data set using OpenRefine, created a folder and a project name. We verified several initial pre-processing that the automatically selected data in a CSV format. Um, for, Further analyzing the product name column is to see there are several records with comma included in them, which can cause some problems evaluating and analyzing this data set. So we need to replace these commas with hyphens. In order to do so, we use the transform function where uh, we use this expression, and on the confirm and in the previous section we can see that are approximately 2000 values replaced from comma to hyphen. And in the product name column, we can verify that the comma has been replaced by hyphen. As part 2, we were supposed to verify the state names using the state name column on the drop-down column of the states and using the text facets option, we do see that there are 49 states included in our data set with no duplicates or wrong spellings. Also observe that most of the transactions are from Florida and Illinois state. We do observe that there are some missing states, but there seem to be no error in a data set for state names. Moving on to zip codes, we use the drop-down arrow for column postal codes to open the menu, and clicking on text facets, we do see that we have several 4 and 5 digit codes. US zip codes are always 5-digit longs. The 3-digit or 4-digit actually means either the zip code is wrong or it's missing a trailing leading 0. To further analyze, we used an expression to group all 5-digit codes as valid zip codes. In our data, there were 9556 codes as 5-digit codes out of 9994 total records. The most common zip code here we do see is these are the 4-digit zip codes, and the most common used zip code is 1841. So we actually Googled and verified these zip codes if they're valid, and do see that 1841 is for Lawrence City and 02908 is for Providence City, which leads to a conclusion that the zip codes are valid, but they're missing a leading 0. Then as a next step, we grouped together our 4-digit zip codes as non-valid and used this expression. And we can see that all data set comes under the category of valid and non-valid. As a next step, we group all our 4-digit zeros to add a leading 0 in front of them, and using this expression, and we can see that the whole data set comes as a 5-digit 0 and they're all valid. So this is a clean data set that we have saved for further analysis. The next part of the project, part 3, is about Apache Hadoop ecosystem with Hawaii Hive. In order to do that, we uploaded the clean data set to Google Cloud Bucket for the cluster. uh, created a new folder called sales record to store the file using the command to make directory. We verified using the ls-l command that that directory has been created. Next, we copy the sales records clean CSV file from the master to the master node from the GCP bucket using the gsutil command. The command ls-l is used to verify that the file has been saved here successfully. Next, we use the put command, hdfs put command, to upload the CSV file from the local storage of the master node into the sales record folder created in HDFS. We do see the contents of the HDFS folders where the data files are saved after the data files have been uploaded from local storage to the master node to HDFS. Next, we move to Hive. So we run the Hive to analyze the data. We run the following command to start Hive. This is the command to use create a well-defined schema with the details of all the variables and attributes. Variables are defined as being strings and integers or double fields. Using command show tables, it shows that our sales record 1 has been created in Hive. To verify the table being set up correctly, we use several select commands before running our queries. This is query 1, where we're supposed to have the top 5 states where the company has the greatest source of customers. This command tells Hive to find the top 5 states with the highest number of customers for each state. Query 2 is to find the sum of total sales in each zip code region. It displays the top 10 zip codes in a descending order. We can see that the top 3 zip codes are from New York City, and Hive took 6.891 seconds to run this query. The next part 4 is about Apache Hadoop ecosystem with Spark. So and the Spark SQL is a command to open Spark and list all the tables in it. We can see from here that after starting the Spark SQL API, the system connects to Metastore and we can see SQL command line. Show tables is the command that we used in Spark, and it shows that the saved file in Hive, we can see it in here too. Using command select, we just verify that our table is correctly analyzed. And we use the same query as we used in Hive, and do see that California has the highest number at 2,000, followed by New York, Texas, Pennsylvania, and Washington. Running the same query to for top 10 zip codes with highest number of sales figures, we do see that the Spark comes with the same results as Hive, and it took 8.363 seconds to complete the query. In comparison, as a part 5, we're comparing the performance for Hive and versus Spark. So the same query we do see we run across Hive and Spark and recorded the time it took to run the query. We ran 5 queries and used 1 data set from a previous data set for weblog 6 to add one more verification point. Comparing speeds, system performance results from various queries on Hive versus Spark. We see that based on query 1 and 4, which is based on count, we do see that Spark was faster than Hive, MapReduce by approximately 3 to 4 times in performing the queries, whereas query 2 and 4, where the results are for some, we do see Hive MapReduce was faster than Hive. MapReduce in general uh, and Spark both uses Hive Metastore to understand the structure of data. Hive is dependent on MapReduce to run its queries, whereas Spark is able to run in memory and perform tasks on its own. When a command is submitted to Hive, it converts the SQL query into Hadoop MapReduce jobs, which are then turn in MapReduce to produce the results. And this process generally takes time, whereas Spark is able to process data and in-memory computations, which makes it independent of the Hadoop MapReduce when running its queries, since it runs it by itself and is able to run faster and finish jobs faster than Hive. So as a conclusion, we do see MapReduce is able to outperform Spark, and based on these observations, seems that tasks involving submission of numerical data appears to be easier for MapReduce to perform than those involving counting the frequency of certain records of occurrence. This brings to conclude my presentation. Thank you for watching, and I hope you enjoyed it.